Alright, so this is the review for the factoring quiz, section 5.3. The first two problems start out as what I would call basic or normal factoring. You're going to look at this and say I have a regular x squared right here, which means that normally you can start this out by just putting two sets of parentheses, starting each one with an x. If you're going to then factor it, the pattern for these is that the two numbers that would go here and here multiply to give you this, and add to give you this number. So you have to kind of think about it a little bit, but basically if you think it out, you could say, well, if it's positive 5 and negative 1, that would give me, multiplied would give me negative 5, and added would give me positive 4. This is the correct factoring then. And so you can say, look, what does it take to make one of these things in parentheses equal 0? Well, in that case, x would have to be negative 5, and in this case, x would have to be positive 1, and that would be factored, and give the final answer we found with 0. So the thing about this is, when you look at these problems, you can kind of start to notice a pattern. Anytime you have a positive in here, the answer is just a negative. Anytime you have a negative in here, the answer is a positive. Similar pattern to almost all of them. So when we look at number 2, we'll be saying the same thing. Look, I see a regular x squared here. I'm thinking it's probably just general factoring, so I'll put x and x. Now I need two numbers to multiply to give me positive 6, and also add to give me negative 7. Maybe it takes an extra second to think about it, but you would come up with negative 6 and negative 1. Again, multiplied gives you positive 6. Adding those gives you negative 7. So your final answers are x equals 1 and x equals 6. For the second part of this, it's basically the same idea, except when you're looking at this, you've got to be able to recognize that there's now a number here in front of the x squared, which makes it a little bit harder to factor. You can't just do it by normal factoring right away. So you want to try, if you can, to get just an x squared here. So this 5, if you can get rid of it somehow, would be an ideal situation. So you should divide it all by 5, because it goes into everything here. So we have x squared minus 4x plus 4. That 5 is called a greatest common factor, and what you do is take it out of all of those. Now keep in mind, it's going to equal 0. So again, now we have a regular x squared here. I would start this off with just x's, and say two numbers that multiply to give me positive 4, and also add to give me negative 4. That would be negative 2 and negative 2. If you stop for a second and look at that, they're the exact same factors. So this one actually fits another pattern called perfect square trinomial. But basically what you need to recognize is that that is equal to this. It means the same thing. And so realistically, the answer to this is just x equals 2. You don't need to write it twice like you would have written here. So if we go to number 4, looking at it in the same fashion, I see a negative 4 here that I'd rather it not be there. So I'm going to see if that will divide evenly into the other ones, and it does. So again, I will divide away the negative 4, so that I have x squared, negative 6x, and positive 9. And again, I see a regular x squared, so I'm thinking right away, factor it like normal, put x's there. Two numbers to multiply to give 9, and add to give negative 6. It's going to work just like the last one happened to work out, where again we have the same factor. It doesn't always happen this way, but this time it did again. So we should write it as this and just say one answer, x equals 3. Okay, so just keeping with the theme of the trinomials here. Again, we look at number 5 and I see, okay, I have an x squared, but I have that number there that I don't want, if I can help it. So I should divide everything out, but I can't divide these by 25, so that doesn't really work. So your third alternative is perfect square trinomial, which is where you would factor like this. And you can only do this if this is a perfect square and this is a perfect square. Or another way to say it is, if this has an easy square root and this has an easy square root, you should be able to do this. So the square root of 25x squared goes here, that's 5x. And the square root of 16 is 4, it goes here. So the only thing left is the sign in here, and that's always this sign. So that sign right there belongs here. And so you have factored something that looks like it's relatively complex, and you've really got it into one simple factor. The only thing is to figure out what x actually is, and this time we will set it equal to 0, and we just solve it out a little bit here. Simple algebra, subtract 4, and divide by 5. And we end up with negative 4 over 5 as a final solution. So for number 6, you're looking at it from the same kind of context. I see a 4 here that I really don't want. Can I divide it out like a common factor? Well, it would go into 20, but it doesn't go into 25, so I can't divide it away. So my other alternative, if possible, is perfect square trinomial. Can I square root this? Yes. Can I square root this? Yes. So it is likely to be perfect square trinomial, 2x and 5. And I use this sign in the middle. So I got to solve it again, just like I did the one above it. 2x minus 5, set it equal to 0. I'd add 5, and I divide by 2. And I get, again, just one answer to these. So that takes me to these problems, which, again, if I'm looking at it, I see a number here in front of the x squared, and I really would not like to have that there. So I try to divide it out. But 2 does not divide here, so I can't take out the common factor. There isn't one. And perfect square trinomial, like we just did, if I look at this, I cannot square root that, and I cannot square root this. So I'm stuck with the most basic general form of factoring again. But it might be a little more difficult, because this time I can't just say I have an x and an x. I have to get this 2x squared involved in it somehow. So maybe instead of an x, I'll put a 2x there and an x here. And now what I have, if I were to do FOIL to check it, 2x times x is 2x squared. That's how I come up with that. So the rest of it, though, is to figure out the numbers that go here and here. The thing is you really don't have much of an idea what they are, except that you still know that they have to multiply to give negative 10. But the rule about adding to get the middle number only works if it's an x and an x. If you don't have that, like we do not in this problem, then that rule about adding to the middle number doesn't work. So we really have to just continue to focus on what two numbers multiply to give us negative 10, and then just see if they work. So these are some of the things over here that could give you negative 10 if you multiply it. That's about it. So I would look at that and say that I know that somehow with these two numbers, if I were to do FOIL as a check, I should get this as an answer. Well, I'm just going to use a little bit of logical reasoning here and say that I don't think there's any way you could put 10 and 1 together, even with this stuff, and get a +1 out of it in the middle. So I'm going to just say, I'm not going to worry about these. And I might go back to them only if the other stuff doesn't work. Because I'm just taking a guess and saying that if I have to do a little trial and error, I'm going to try to minimize how much trial and error I have to do. So I'm going to take the first set that I have right here, 2 and negative 5. And by the way, if you aren't already, you should be using a pencil to do these, because you might have to do some erasing, and you really should keep this as clean of a problem as you possibly can. So just to see how it works, I'm going to stick in the positive 2 here and the negative 5 here. And now I'm going to do FOIL, first, outer, inner, last, to see if it works. Well, okay, 2x and x can give me 2x squared, which is okay. Outside is going to give me negative 10x. See, I'm already worried about that. And then I got 2x in the middle. Well, see, like when I would go to combine like terms, negative 10 and positive 2 is not going to leave me with the positive 1 that I want. So that means that those numbers are not correct. So these cannot be right. Doesn't mean I give up on those numbers, though. I try it again, except this time I flip it around. I'll put the negative 5 here and the positive 2 here. Again, you can check it doing FOIL. You know you're going to get the 2x squared. We didn't change that. Outside will give you 4x. Inside, negative 5x. Again, you put them together, you get negative 1x. Getting a little closer, but that still doesn't work. So it can't be those either. But I did recognize something in all of that. I noticed that it seems to work better there if I put the 5 here and the 2 here. So I'm going to put negative 2 here and positive 5 here. That's this one. If I do FOIL, 2x squared, outside would be negative 4x, inside would be positive 5x. Those two together give me positive 1, which is what I want. So I finally found the correct factor. So sometimes you can get a little bit of a handle on this. Once you get a little practice, you might not have to go through so much of that, or at least you can do the FOIL in your head so that you don't have to keep writing it and erasing it. But okay, we're stuck with finding the factors now. We did that. Let's get an answer here. That's x equals 2, no problem. And this one, 2x plus 5, we just got to make it equal 0. And again, this might be one of those things where you can start to see a pattern in the answers. So maybe you don't have to show all that work. Those are your final answers for that one. So here we are again in number 8 with the same idea. I want this 2 to go away, but I can't divide it through. And it's not an easy square root. This one is, but this is not. So that doesn't work. So again, I've got to factor it in probably the most complex way. Let's put a 2x here and an x here. Okay, so now I need two numbers to multiply to give me 4. And then I somehow have to get 9 out of it. Well, just on a guess, I'm thinking that I might need to multiply this 2x by a 4. So there's a 4 here, and I'm going to put a 1 here. And if I did FOIL, I would get 2x squared. Outside would give me 8x. Inside would give me 1x. Together, there's the 9x. And then 1 times 4 is 4. So these factors turn out to be correct. And like I said, once you get the hang of it, sometimes you guess them on the first try. And this one, 2x plus 1 equals 0 again. I subtract 1 and then divide by 2. These are my two answers for these. Okay, number 9 and 10, this is a factoring method called difference of two squares. They're real easy to spot because there's only two terms. And second of all, they're actually problems that I don't know if factoring is the fastest way. I might do it a different way. But nonetheless, this is what they showed you to do, so let's do it by factoring. And a little later on, we'll learn how to do it the much easier way, in my opinion. But this has to equal 0, so subtract the 81 from both sides. That way it equals 0. Now you have two perfect squares and a difference between them. If that's what you have, you can put it as a special factoring, one with a plus, one with a minus. Square root the first term here and here. And square root the second term here and here. So if you notice, these things are almost identical except they're different signs, which means that our answers will be identical except that they'll be different signs. So just to figure it out one time, 2x minus 9 equals 0. I'd add 9, and then I'd divide by 2. I get 9 over 2. That's one of my answers. The other answer would be its opposite sign, so the other answer would be negative 9 over 2. So. Number 10 is actually already set up for you. It's already set equal to 0. So as a difference of two squares again, plus and minus, that's 4x. That is 8. So what I end up with here, when you work it out, is x equals 8 over 4, in other words, 2. That means this one would equal negative 8 over 4, or negative 2. So we're on to the very last type of problem. These are the times when the answers are given to you, and they ask you to return it to a quadratic function. So the first thing you want to recognize is that these answers you get are the result of what happens when you factor, like this. See, x equals 2 was our answer, but that came from a factor of x minus 2. So what I want to do is turn these things back into what their factors would have been. Our answer is positive, so our factor would have been negative. And this answer is negative, so our factor would have been a positive number. And now to multiply together, you've got to use FOIL again. X times x, outside is 2x, inside negative 5x, and last is negative 10. Combine like terms, you got x squared minus 3x minus 10. Final answer, that's your quadratic function. Okay, with number 12, it's a little bit more complicated because you're dealing with a fraction here instead. So if you go back and look at some of our answers that we got fractions for, they were a little bit more of a complex factor than just an x and a number. They're usually not too bad. So if you look at this, what you really want is this to equal 0. So if you start by multiplying it by 3, that'll cancel the 3 out, and you got 3x equals 2. Then, to make it equal 0, just subtract the 2. 3x minus 2 equals 0. As soon as you get something that actually equals 0, this is your factor. So 3x minus 2 is the factor we'll be using. This one, multiplied by 5. Now you got 5x equals negative 6. Add the 6 both sides, and you got 5x plus 6 equals 0. This is our factor, 5x. Sorry about that. 5x plus 6. So we're not done. We did a little bit more work this time, but we're not done yet. We do have to do FOIL. So first term would give us 15x squared. Outside would give us 18x. Inside would give us negative 10x. And last would give us negative 12. Combine these like terms, and you got 15x squared. These two go together, so plus 8x and minus 12. That is the final answer. So if we go back through all of these things just very quickly, there's two lessons to be learned here. One is actually how to do the problem, but two is how to recognize the easiest way to do the problem. So in the case of number 1 and 2, the simple factoring, you're normally looking for just an x squared with nothing in front of it. These ones were basically like that, except that you had a number here, but you could divide it through. So if you can, you should look for a greatest common factor before you do your problem. If the greatest common factor thing doesn't work out, then you should try to check and see if it's perfect square trinomial, where this would be an easy square root and this would be an easy square root. And finally, if none of that works, and you still have a number in front there, then you're going to be stuck putting the two factors in the beginning that will somehow give you that first number, the first term. So it's kind of like the last resort thing, but it does happen occasionally when the quadratics are maybe a little more complex. And then, of course, these difference of two squares, easy to spot because they only have two terms. And finally, we turn it back into a quadratic thing. Seems like most people don't have much trouble with this, because basically it's an exercise in how to do FOIL or not. Okay, your test is on Thursday, March 1st.